Hello everyone, welcome to this tutorial. My name is Xing and I'm a software engineer with special interest in computer graphics and digital geometry. In this tutorial, I'll share with you how to wrap C++ native code in C#. We will use CGAL library in Grasshopper as an example. Here comes the spoiler. You may wonder, what is the outcome of this tutorial? Let me show you. Well, after this tutorial, you should be able to wrap an oriented bounding box algorithm from CGAL to Grasshopper from scratch. As you may know, the bounding box in Grasshopper is actually the axis-aligned bounding box. The edges are aligned with XYZ axis. In this tutorial, we use the oriented bounding box. It is the box with minimum volume. So let's get started. Before we get started, I would like to mention that this tutorial and the core methods, I would say, refers to the guys from MacNew, the developer, Rhino 3D, Dan's wrapping native libraries, and Giulio's using methodgen, and also some code from the plugin Cockroach developed by EPFL researchers Petras and Andrea. It's also a great reference to this tutorial. Thank you to them. In the meanwhile, I have to admit, I am not an expert in C++ and C#. So if you found any mistakes that I made, and you have any suggestions, please leave the comments below. Also, I hope this tutorial will cover the very basics for beginners. So if you are guru, please feel free to speed up or skip some parts of this tutorial. In order to develop this plugin, let's first check if you have installed every tool. You have to install Visual Studio and select the .NET Desktop Development and Desktop Development with C++ in the Workloads section. In the Individual Component section, select MFC, then check if you have installed Git. We will use Git to install VC Package. I want to very briefly mention VC Package here. VC Package is the most application I like among all the tools of C++, which can help you manage C and C++ code and the libraries. You don't have to explicitly include C and C++ libraries by yourself. We will demonstrate that later. VC package installed, the CGAL library dependency can be easily solved. You can follow the instruction here. The final tool you have to install is the Visual Studio extension of Rhino and Grasshopper. You can choose the template in light of your Visual Studio version. That's all the things you have to install. So let's get started. We first step back from the technical stuff and take a look in a bigger picture. So the first question is to ask ourselves, why? Why wrapping native code? I think speaking in the perspective of a developer, you will have to benefit using lots of libraries which have been developed for years. For example, in geometry processing domain, there are CGAL, libigl, Open3D, and PCL. Another key reason I favor C++ library is the fast numeric computation. From my personal experience, I currently can't find a fast and a robust numeric computation library in C#. Well, in its relevant topic, you may hear things like unsafe, native, unmanaged, managed. So what does it mean? I think when you heard of these terms, please think of CLR, the Common Language Runtime. To put it very simply, managed code, aka C# code, is just that code whose execution is managed by CLR. For example, you don't need to consider memory management, type safety, etc. And to the way you will run a C or C++ program, also called unmanaged code. In the unmanaged world, the programmer is in charge of pretty much everything. Like I said before, you must consider memory management, type safety, etc. So if you're a beginner, just like me, you can just say unmanaged code is C++ code and managed code is C# code. That's it. Another thing you may look familiar is the platform invoke, pinvoke for short. This is the technology which allows C# code to call functions that are implemented in a C or C++ DLL in Windows or dilib in macOS. For simplicity, please just see it as a bus, as a delegate between C# and C++. The other close related domain is called shell. Imagine there are double type in C++ and also double type in C#. This is the guy who is responsible to transform these data back and forth. So for simplicity, as again, please imagine it as the magician who can transform things. Cool. The brief introduction is done. So if you're not so sure about the concepts and the definitions, please don't worry. Things will get clearer after you start coding. In the following section, I will briefly introduce you the fundamental behind this topic. So as usual, let's look at a bigger picture, the layout of our solution. So first, we have the C++ project. We name it with native prefix. And second, we use C# code to wrap the C++ code. We call it wrapper. Then we have the application project, which could be either WPF, WinForm, etc. But in our tutorial, it is the Grasshopper plugin. Okay, with that bigger picture in mind, we zoom in a file details. The blue dots stand for files from C++ and purple for C#. In this case, the .gha file of a Grasshopper, the invoke order is that first in .gha file, then to C# DLL, then to C++ DLL, and back and forth. So for this stage, just keep in mind that both C++ and C# DLL should be in the same folder as the application file. That's the key idea. So invoke DLL from the application directory is just one of few search paths. The DLL search paths and order is the following. For example, you can invoke user32.dll in the system directory. Okay, for the last piece of fundamental knowledge, I want to mention marshalling types in C#. This is key and core of this tutorial because it helps us convert the specific type in between C# and C++. Here I list few examples, like pointer from C++ to C# is int pointer. The array of floating point array in C++ is written as D star. It's the pointer of a double array. Okay, when it converted to C#, is the double array, like the form in here, etc., etc. For the full marshalling conversion type, I enclose the links in the description of this video. Now you have everything to get started. So let's dive in designing the algorithms and coding of CGAL bounding box. Suppose you have zero knowledge on CGAL. Please don't worry. Guess what? You can also use it. I'll show you how to do that. So first, open the browser. Let's search the keyword CGAL oriented bounding box. The quickest way to know how the OBB algorithm works is take a look at the example. At the first glance, there are few lines here, but the core of this example is three things. Think about von Neumann architecture. This is the computing, which is exactly the oriented bounding box function. This is the input, something called surface mesh. This is the output. And there are 8 points, which are the vertices of the box. Now, let's take a look how to construct a surface mesh. Just click the link of surface mesh mentioned in the example. As usual, take a look at one of the example. You can see that a vertex is composed by a point 3, and a point 3 is composed by 3 values, x, y, z. This is very common in computer graphics and computational geometry. Next step, they construct a mesh face by the index of vertices. This is the input. For output, it is pretty much the same. The outputs are with type point 3 as well. So we open the documentation of point 3. And scroll. Okay, found it. The creation is 3 floating point values, x, y, z. Excellent. We more or less understand how to use CGAL function and data type. For great practice, we wrote out the input, processing, and the output for archive and later reference. Now let's step back to take a look at Rhino and Grasshopper. The mesh data structure is more or less the same across different geometry processing library, so as Rhino Common. Here I already made a tetrahedron with 4 mesh faces and 4 mesh vertices. Take the last mesh face as example, which is the leftmost mesh face. It is composed by 3 vertices, and the vertex index are 2, 1, 3. And the coordinates of 2, 1, 3 vertices can be found in the preceding vertex information, 2, 1, 3. Cool. Now we have the context in both Rhino Grasshopper and CGAL. So let's design the algorithm and procedure. Here I made a diagram of all the steps we need to do. The first step is to extract all the information from Rhino side, including info like vertices and faces. Next, we convert the info from Rhino mesh to a CGAL surface mesh. We then run the bounding box algorithm in CGAL. Its result is a bounding box with 8 points. We then extract the info from 8 points in CGAL, finally convert back to the point 3D of Rhino. Excellent. This is the whole idea of this tutorial. So how could I pass the information of vertices and faces from C# to C++? So try to recall the topics I mentioned earlier. How can we transform such information to Michel types? If you like, you can pause the video here and think about it for a moment. Okay, welcome back. For me, I will do it as the following. Each coordinate of a vertex is composed by 3 values, x, y, z. So there are 4 vertices here. So the total amount of these information is 3 times 4. That is the array of 1, 1, 0. So we can concatenate the whole information into one array. That is, for the 0 index vertex is 1, 1, 0. So for the 1 index vertex is 0, 1, 1. The same is the following is the same. 0, 1, 0. 0, 0, 0. So this is the double array. like this. So this is we can convert to the double array. For the mesh faces, it is the same. So we have the first mesh faces composed by the index 3 vertex and index 2 and index 0 vertex. So we can write it out like 3, 0, 2. For the next mesh face is 3, 0, 1. 3, 0, 1. So the left are more or less the same. So this is the integer array. We can convert here. Okay, that's good. Let's make all this logic in Visual Studio. Let's just create a Grasshopper project. Select the template. Let's just name CGAL dot Grasshopper. Wait. So the solution name can be just CGAL. Hit create. So the component, I would say component CGAL OBB. The name of it is oriented bounding box. Nickname OBB. Category mesh. Utility description. This is the oriented bounding box using CGAL algorithm. Okay, so let's hit finish. Cool. So let's register the input. The input is a mesh. Nickname. Is just one item. So the output is point. Nickname P. The A point of the bounding box. First, let's declare the input. Retrieve the data. If it's not succeed, just return. Oh, sorry, not set data, get data. Okay, so the first step is to clean and combine the mesh. Because you cannot rely on user who provides you a perfect mesh. So the first step, I would say clean and combine the mesh. So here I make a duplicate. Since mesh is a reference type, so we create a duplicate mesh which does not affect the original one. Okay. So the vertices value xyz, we use double precision. Fine. True. And we have to make sure the input mesh is triangle mesh. Then we need to combine some identical, true. Then we call the unused vertices. Weld it with pi. Fill it. And finally, rebuild it. Cool. So here the mesh, the duplicate mesh is finished. So we have to check if it's valid, and it's also have to close. If it's not, just return. Okay. So what we have to do, let's make some notes here. The first step is we have to extract the info of vertices. The info includes the x, y, z coordinates. Let me draw some Ask art here to demonstrate the info of a mesh. So here's the mesh. Suppose you have 3 vertices. So index 0 is 1, 0, 0. And index 1 vertex is 0, 1, 0. Index 2 vertex 0, 0, 1. Okay. As we said before, we can concatenate them into one double array. So in the end, you will have 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, cool. So let's do that. So we declare the double array. We call it vertex xyz array. So what is the length? As we said before, is the amount of vertices times 3. Okay. So we need to make a for loop. Visual Studio suggests us to do that. Okay. So we make a for loop to loop over this value. So the words xyz array. Here I made a I times 3 plus 0. So this is vertices. Point 3D at current point, and the value is x. Okay. So we made 2 copy. Here I explain a little bit. So suppose the index I is 0, so this is the point. So here is x. Oops, sorry, I forgot to modify. So here is x, so it's 1, y is 0, and z is 0. So because the index is 1, so we have to plus 0. Plus 0 is this one. Plus 1 is this one. And plus 2 is this one. Okay. So the amount of array is that vertex count could end vertices dot count. Okay, I think I made something different here. I made unsigned long. Why is that? Because the vertices of a mesh sometimes can go up to million. So just in case our function still work, I declare as unsigned long here. Okay. Okay, now turns to the info of the mesh faces. So let me copy the comments of vertices. Okay, info of mesh faces, just faces. The face indices of a mesh. Let me use the diagram in the presentation. So 3, 0, 2. Maybe I'm wrong, so here's just a demonstration, not a big deal. 1. More or less like this. So the value is concatenate 302, 301, 021, 213. Cool. So this is the integer array. So we name it face index array equal. For the face info, there is a very useful method provided by Rhino common. It's called what? Called toInt somewhat. Yeah, toInt array. Okay. So or as triangle, of course. True. Okay. So the faces count are more or less the same. Face count. Unsigned long. Cool. Perfect. The input from the Rhino mesh is done. So let's move on to the next step. So step 2, import the info from Rhino mesh and build the CGAL mesh. Let's create a C++ project. MFC, dynamic link library. Let's call CGAL.native. This is by convention. Just hit OK. I want to talk a little bit about C++. For those C# developer who is not familiar with C++. So this is the boilerplate of a C++ project. I would like to highlight 3 things. So the first one is these header files. C++ programmers tend to put function prototypes here. It is pretty much similar to the interface in C#. Its complement is this source files, which actually implements the function. For simplicity, just think of them as one is an egg and one is the trick. The last important file I want to mention is this pch.h file called precompile header file. The purpose of this file is to speed up the build process. Normally, we will put stable headers file like standard library. In this case, we will put CGAL libraries in this file. In order to export C++ code, you have to declare it with this prefix. In Windows, you have this one. In Apple, you have this one. By decorating with this line, the linker will add information to the DLL that makes these functions public. Without this decoration, these functions will not be available outside of the assembly, such as in Windows, DLL, and in Mac OS is the dylib. You also notice the difference of decoration here. Windows is this one, and the Mac OS is this one. The reasons they are different on each platform is that dynamic link library implemented differently in Windows and Mac OS. So each platform has a unique way of telling the linker what to do with the library. In order to declare function easily, we can put everything in this macro. There are two well-defined sections to this header. One is related to Windows and one is related to macOS system. If you got confused here, please don't worry. How this works is not really important. Just know that you can put these macros in the precompile header file, that is pch.h file. So the next step is think about the bounding box function prototypes. In previous step, we are left with the data of info of vertices and info of faces. And with the knowledge mentioned in previous presentation, we could easily convert the double array in C#, like this one, to here, this one. This is the syntax of double array in C++. So this is one-to-one transformation. So this is ulong from here to here size t. And the integer array in C# and transform to here. So the unsigned long faces count are transformed to here. Great. Now we have the macros and function prototype. Let's put everything together in C++. So first, go to the precompile header file. We put the macros here. Because I already copied it, so I just paste it. I name it in two sections. One is Windows, one is Apple. I declare the macro as the name CGAL native C function. Okay. So the next step is to include the CGAL library. Okay. So I mentioned previously in the presentation, we use VC package to manage the C and C++ library. This is the advantage of VC package. Normally, if you have a C++ project, you would include the libraries here. So that's very complicated and difficult for beginners to implement. Instead, we can use VC package. They already built the CGAL library for us. So as you see, you can include, let's say CGAL. You see, there is a CGAL folder here. Very useful. So we include the libraries in the samples from CGAL official website. So the first one is exact predict blah blah blah. Sorry, I can't remember. Let's just paste it in here. So this is the libraries. I just copied it. Copy. So we just paste here. These three libraries, we don't need to use it. And also copy the type definition. Actually, we need one more thing. Cool. Now we create two files, one in header we name it CGAL.native.functions. We copy the file name. In here, source file. We create a CPP file for the function. So we first declare the function here. So hash include the precompile header file. And then we go to the PCH precompile header file and copy the declaration. So we write out the function prototypes here. Void oriented bounding box by surface mesh. So the input is first of all double array XYZ array. The amount of vertices. The integer array. Okay, here is the function prototypes. Now we implement the function in CPP file. Let's copy this one. Hash include CGAL.method.functions.h. So first of all, we have to declare a mesh. First clear it, and reserve the amount of vertices and reserve the amount of faces. Okay, so we need to fill it. This is pretty much the same as in Rhino mesh. So mesh.addVertex. Oops. So a vertex is a 0.3. A 0.3 is composed by XYZ value. So as you remember, we have this one. First value is 3 times I plus 0. So this is X, this is Y, this is Z. Okay. So next is the fill the info of mesh faces. For loop. Faces count. So mesh.addFace. Okay. So range of vertex and index. SM vertex index. Okay. So vertex index. Okay. So the first index is from the face index array. I times 3 plus 0. So this is the first one. Okay, cool. Now we have the mesh info from Rhino in CGAL. So the next step is pretty easy. Just run the bounding box function in CGAL. So declare the output, which is an array of 0.3, 8 points, we name it OBB points. So we fill it in the function CGAL oriented bounding box. The first argument is let's see. Polygon mesh. So mesh output is OBB point, and there is an argument called use convex hull. Okay, done. Now we move to step 4. So we already have the outcome of the bounding box function, which are 8 points of the bounding box. So now we want to extract the XYZ value of each point. So first, I declare a double array called OBB points XYZ. Okay. The length of it is OBB points dot size times 3. So the amount of it is OBB points count. Okay. So first, for loop the points. So what's inside the point? So in here they got x. This is x value, and this is y value. Okay. So we need to put the set values in this array. So BB. Okay. We also mind. So I think we need something to document the value. So we use I here and pass the x. Okay. So now is index 0, right? So we need to increment it. Okay, actually, we can replace like so. Okay. OBB1 I plus plus. So this is y value. So after setting all the x, y, z value, so we're here to increment the amount of the point. So the OBB point is this amount. Okay. And here's the thing. So this is the output. Also, this is the output. But in our function, we don't have anything to output the output. So we need to modify it. The function definition here, we need to have, so this is input. We can have output here, double, what is it called? XYZ array. And this is point count. And actually, you need to do is that you need to modify it to a reference, pass by reference, because in the future, these functions will be passed out to the C# code. Yeah. So copy this one. Okay. Actually, I think I did something silly here because I explicitly stated that the output is 8 points, but here I counted, so I think it is not necessary. So let me delete it. So the function we need to modify as well. So we just need to explore the XYZ value. That's it. But made a good habit, although it's a void function, we return void. One thing I want to point out is the difference of memory management in C# and C++. In C#, most of the time, you don't need to take it into consideration, while in C++, you have to do it manually. For our code, we declare a double array with the new keyword to explore the XYZ value for 8 points. That array is exactly what we need to destroy. So I supplement a release function to destroy that pointer of array. So we come back to Visual Studio, go to the function prototypes, CGAL, whatever, copied it. The function is called void release double array. Stop. Implement it in here. That's it. This is the final step. Now we really want to integrate C++ and C#. Let me summarize a bit what we have done so far. We have the info of a Rhino mesh regarding vertices and mesh faces. We pass them into CGAL, and we have the result as 8 points. The XYZ value have been extracted and stored them in an array. So somehow we need to read it back to C#. So this is the crucial part, the intersection between C++ and C#. I haven't done so far, so let's do it. A wrapper, class library, CGAL dot wrapper. We will create 2 classes. One is called unsafe native methods. Another one is called, let's call polygon mesh processing. This is the name from CGAL. We modify the polygon class to public. The unsafe native methods is internal. I want to briefly talk about the solution structure here. The wrapper can be seen as the mediator between C# client code and C++ native code by convention. Also, this is the convention recommended by McNeil. We make a class called unsafe native methods, like this one, and in the meantime, set to be internal. The reason why it is internal is that we don't want it to be exposed by others, so these guys cannot read directly or use directly the function in unsafe native methods. On top of unsafe class, we have a class called polygon mesh processing. This is the class in the same namespace as the unsafe class. It uses unsafe method and should become the base method It is public, which means this wrapper project can not only be used by Grasshopper project. In the future, if you have WPF project or WinForm project, they can use the polygon mesh processing library, like this one in here. That's the whole idea of a wrapper. The next thing I want to talk about is the attribute started with the DLL import. This is exactly the p-involve technology. We just need to notice three things. First is the DLL name. It should be constant. Second is the calling convention here. It should be the same as we define in C++. The mashal as attribute indicates how to mashal the data between managed and unmanaged code. So let's first declare the name, constant, native .dl. So let's just copy the function prototype. So we paste the declaration here. So it's the attribute is DLL import. Okay, so the first is DLL name, calling convention is zero. Okay, so we comment that out. So this one can be same here. So we modify the C++ array into C# array. So here is ulong. Integer array, also ulong. So this is because this is pointer reference, so you need to make it as int point. Oops. Static. Yeah, sorry. So you have to set the internal static string. Okay. So for the double declaration, we need to use mashal s. So we got mashal s unmanaged type dot lp array. Okay, cool. Copy this attribute here, the integer as well. Okay. So the next function, release. Same, double array, internal, static, external. Okay, cool. Now we have the unsafe native methods. Oops, sorry, I forgot. This guy is not the double, it's int pointer. And also, because this is return type, you have to add reference. So we copy the method made before. Copy here, crop it, and make a function here. So public, we want static. We want to return this point 3D. And this is called OBB as point 3D. The input is mesh. Sorry, mesh. Because the Grasshopper and Rhino common is not installed in this project, so we need to do that. Hit manage NuGet package. So we hit wrapper, install. Okay, so we need to multi-select the Rhino and Grasshopper reference, copy to local sec to forms. Okay, come back here, control dot. So this is return null. Okay, now we have the inputs. So let's put it into the unsafe native methods. So we have the declare output pointer OBB XYZ pointer. So we put it in CGAL function. So here we invoke the unsafe native methods dot orient a bounding box by surface mesh. The input is, the first one is vertex XYZ value array, and vertex count, and face index array, and faces count, and finally the output, the OBB XYZ pointer. Cool. So now we have the C++ double array. We need to transform to C# double array. So double. We name it OBB XYZ array equal new double. So the size of it is 8 points times 3, because each point has 3 values. We then use Michelle.copy to copy the value from the pointer to C# array. OBB XYZ pointer. OBB XYZ array. From 0 to 24. Okay. So then we convert C# double array to list point 3D. So we made a for loop. So we declare so we fill it for loop. The length is OBB XYZ array dot length. Okay, so points dot add new point 3D. So x value is OBB XYZ array I plus 0. So let's copy. I think we need to increment 3 here, because each iteration we have 3 values. Yes, that's why we need to increment by 3. Cool. So we have used the pointer. Now we need to delete it. Unsafe native methods dot release double array pointer. Cool. Okay. So finally we return points. Okay. So we move to here. Call the function polygon mesh processing. Add the reference dot vvx.3d mesh as an input. So finally, we set the data list. Okay, cool. The next step, we need to build and debug the project. So I want to briefly talk about the build dependencies and the build order of our solution. So first, we have the C++ library build, and because we need to use in a global perspective, so we copy that out to the dependency folder I manually created, and the next step is to build the wrapper. DLL must be with C++ DLL together, so we put it here. And finally, this is the application folder. So we can have C# DLL, the wrapper, C++ DLL, and finally the application file here. So if you want to debug C++ code in C#, you have to check three things. First, you have to check the unsafe code, the checkbox is checked. You have to enable native code debugging. The final step is quite important because we need to debug in the Grasshopper application. So we need to set the build dependency of CGAL wrapper and also the CGAL native. That's all the things we need to set up in Visual Studio. So let's do that. So first, let's check the C++ library. So we need to add it as to the dependency. So we hit macro, solution, directory, dependency, configuration. So that is to debug or release mode. Okay. Apply, set to OK. Then we go to wrapper. We need to do that as well. All configuration. 64 is save. Go to the build event. So we type as copy the solution directory dependency configuration and copy to target directory. So this is the wrapper. And also you need to hit some. So hit there is a allow unsafe code. Go to debug. We hit the enable native code debugging. Save it. Now we turn to Grasshopper project. So let's search unsafe. So click here, debug. Open the dialog. So in the bottom, you will see enable native code debugging. Cool. So next thing we need to do is the event. We hit X copy target directory. We copy to the libraries of Grasshopper. So user profile app data Grasshopper libraries So we to the name, project name /s/1. Then we need to rename the DLL to .gh file. So hit copy. Copy this whole string to here. Project name / project name .gha. So here is the target path. Target path means the grasshopper.win.dll. Target path. Okay, cool. Next thing we need is to set the build dependency. So project dependency depends on native. Here we need to set build dependency native. Hit OK. So first check the wrapper if can build. Okay. Redefinition of formal parameter. Oops. In here. Redefinition. Sorry, because I forgot to delete this guy. So because this has name as output, so I forgot to delete the decoration. Sorry. So let's just hit one more time. Okay, the command X copy build event. I think I missed a dollar symbol here. So that's why it cannot recognize as the absolute path. So let's hit build again. Sorry. So here it says dependency. So we missed a / symbol here. Sorry for the mistakes. But it's good. It's good. We can debug. Okay, is that build succeed? Let's see what's inside the folder. Bin debug. Oh, cool. We have wrapper and native libraries. That's cool. So let's just hit build the Grasshopper project. Failed. Let's go to here to see what's going on. The command blah 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 blah. Oh, sorry. This is not pre-build event. This should be post-build event. So in pre-build events, we need to copy the things in here as well. Okay, now it should work. Okay, cool. Build succeed. So before that, we need to just remind that there is something you should set in Rhino. So make sure you have set Grasshopper developer settings. You have to put the path of Grasshopper plugins in here. So just hit OK because I already put it. Close it. Let's see if we can debug. So I made some breakpoint here. So first one is here. Native methods. Sorry, polygon mesh. So let's check if we can debug in the C++ project. So let's go. Hit OK. Debug. Go. So here I have a mesh. So we go to the mesh utility. This is the plugin we made. And plugin. Cool. Let's get inside. So hit step into. So everything works well. So here we hit continue. Here we add the points it's about to go into the C++ code. So we hit step into. Cool. Now you see we're in the C++ debug. So we can debug C++ code in C#. So let's hit step, step, step. Okay, cool. Now hit a breakpoint here. So we hit continue. Now the mesh filled with vertices. So we can check mesh vertex properties. So here is the size. I think it is okay. So we hit a breakpoint here. So let's hit continue. Cool. Now the point is in here. So we can see the output is OBB points. We have eight points. So as we can see, this is 1 point and we have XYZ value. Cool. So let's hit continue and see if we got the bounding box. Cool. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 points of the bounding box. But it's just point. So let me modify a little bit to have it as a BREP. Okay. So we go back to the polygon mesh processing function. So I name functions public static. So the return, I suppose, is a box. So OBB as box. So the input is still a match. So we got the points here. We use the OBB as point 3D. So now we have the, sorry, I forgot to declare the variable. New box. So here you have a base plan, and I remember there was some points. Yeah, we use this overload function, base plan and point. So we hit plan, new plan. Oh, cool! It helps us to create a new plan. So box. So first value is plan, and second is point. So return box. Now we can also create a function to return BREP, public static BREP OBB as BREP. The input is still a mesh. So we can say return polygon mesh processing dot OBB as box. We put the mesh inside. There is a toBREP function of the box. Okay, cool. So we go back to Grasshopper, and I modify the outputs. So first, add a box, the bounding box as a box. It's hilarious. So item p manager at BREP. The bounding box as a BREP. So we can set data on 1 polygon mesh processing OBB as box. So here as BREP. Data set to true. Okay. So next thing I want to show you is that we can change the debug mode to release mode and also select 64. So now I bring back the libraries of the Grasshopper. So now we can see the native code is like 2000. Let's hit build. We can take a look. What's the size can be reduced to? Cool, you see? The native library has reduced to 300 KB. That's quite a lot. Let's go back to Rhino and see if the update version of our plugin. So we use this one as well. Utility, Now we can have 3 outputs. Let's see what's the outcome. Cool. Now we have a box. So this is box, this one, and debug, and this one. Cool. So let's see. We modify a little bit. So turn around. Oops. I haven't set yet. Cool. So let's turn around. Okay, perfect. Let me summarize what we have done today. First, you have installed all the tools needed. You are seeing in a bigger picture why should we wrap C++ code in C# and what kinds of technologies being involved. You are also familiar with the fundamental knowledge to make it happen. In a case study, you understood how to transform Rhino mesh to CGAL surface mesh with only primitive data types in C# and C++ and between them. You also tackle all the problems and steps in Visual Studio with debug and release. Wonderful! If you have any questions and suggestions, please leave the comments below. See you around. Ciao ciao!